So now we want to talk about the full adder. So kind of the issue that we're looking at here is, say we've got uh, this number added to this number in binary, and we're looking specifically at this digit. So we know we're going to have a sum, we're going to have a carry out, and of course we're adding these two bits. But the other thing that we have to worry about is the upstream or the previous calculations, namely this this set of digits and this set of digits. We know that they're probably going, or they could potentially generate a carry in, right? And this carry, or technically this is a carry out, becomes a carry in of this calculation here. So kind of what this looks like if we look at it as a black box, is we're going to have a black box, and it's going to say FA, right? This is a full adder. And of course, we're going to add in our two digits, right? We've got A and B. And we're also going to add in our carry, in which case we're going to call that carry in. The carry in, what we're carrying into this is called the carry in. We've also got a sum, which we're going to call S. And we also know that this could carry out a 1 to the next calculation. So that means we're going to have a C out. Let's see what this looks like as a truth table. So I'm going to list C in first, right, as the most significant. It doesn't necessarily have to be this way, but it's just the way it's most conventionally shown, as C in is your most significant. And then we're going to have A, B, and our outputs are C out and sum. Alright, so it's a 3 input system. So let's get all of our combinations here. We got 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now, what we need to do is just kind of go through in our minds and find all of the combinations, or not, look at all the combinations and see what our results are. So here we know we've got a bunch of zeros added together, and so the result of that should just be a bunch of zeros. 1 plus a bunch of zeros is just a 1. So that means our sum, right? Our sum is our least significant bit here. So sum is 1 and C out is 0. We don't have a carry there. This next one is the same case. Now we've got two 1s added together. Two 1s is going to generate a carry with a sum of 0. Now we're back to the case where we got 1 1 added together. Remember, the carry in has the same value as A and it has the same value as B. These all have the same equal value. They're both a value of 1 if their bit is a 1. So that means here we've got a carry out of 0 and a sum of 1. Here looks like we've got a carry of 1 and a sum of 0. And we also got 2 bits there, so that's a carry out of 1 and a sum of 0. And then finally, we're adding 3 1s together, which is a 3 in binary, which is represented by 1 1. So that means this is our only case where we have a carry out and our sum is a 1. So we've got everything there. Let's look at some K-maps here and see what we can get. So first, let's do sum first. So all right. So we'll draw our K-map. And we're going to have our inputs of, I'm just going to call it Cn, A, and B. So 0, 0, 0, 1, 1, 1, 1, 0, and A, 0, 1. And let's go through and fill these out. So this is 0, 1, 1, 0, 1, 0, 0, 1. Now, when you look at this, this looks very much like a really bad K-map, right? Because you can't really make any implicants. And the traditional stuff that we've learned so far, we can't really do anything with. And it's something that you can look into on your own because we won't really ever do it again in class. But identifying checker patterns in a K-map can also indicate something. Identifying checker patterns can identify some exclusive OR gates in our function. So it's not the traditional sum of products or product of sums. But since the checkered pattern is this specific way and it spans over the entire K-map, what S actually is we can say S equals X, or sorry, not X, my bad, C in exclusive ORed with A exclusive ORed with B. So like I said, Google exclusive ORs with K-maps and look at the rules if you're interested. They're kind of cool. Just another trick that you can have up your sleeve when you're doing K-maps. Now let's look at C out. Our K-map. I just need like a digital stamp that I can drop down for this. So we got C, N, and A, and this is B. 0, 1, 0, 0, 0, 1, 1, 1, and 1, 0. And see what we get here. 0, 0, 0, 1, 0, 1, 1, 1. Alright, so for our implicants here, we don't got much to work with. We just got this guy, and that guy. So what do we end up with? We end up with C out equals, and let's do this column here. Looks like C in and A ORed with. Now we'll do this guy. Looks like A B ORed with. And it looks like this guy is C in B. Yeah, so these are our functions for sum and carry out. It's a function of A, B, and C in. And this is our full adder. And we'll explore the full adder much more and see how we can link them together and do some pretty big calculations with them.